Good afternoon, everyone. Thank you very much for being here today. Thank you for staying safe. This is Panta Rei's webinar number 7 about wastewater treatment, about the sludge treatment with Mr. Mirko Antoni. Please, Mirko, you can start the presentation about the sludge treatment from wastewater treatment plants.
Hello and good morning to everyone. Just a brief introduction about us for anyone who is not familiar with us. We are an Italian company focused on water and wastewater treatment for textile industries, and we are basically present all around the world. We are a higher certified quality company, so we have quality standard certifications, and this is one of our main goals, to provide the top quality products and technical solutions. We are part of the DISC program, which has united partners and contributors with a common goal of guaranteeing water discharge with increasingly stringent parameters as a part of the compromise with environmental sustainability. And we are proud to be part of this organization. We are more than 90 working ETP, and around 65 are located in the Southeast Asia, which is right now our main market. Now we are presenting the webinar schedule. This webinar is about the sludge treatment solution, and the next week we will have the last webinar about the water and brine recovery system. Today, we will make a simple example to check how to calculate the sludge production in the biological system and the sludge which has to be disposed after the dewatering unit. As you know, inside the oxidation tank, there are specialized bacteria able to degrade organic compounds present in the inland water. Inland water represents the food for the bacteria which are able to grow quickly. This biological process is called synthesis. Now, considering this process flow, we can see that only the return sludge is considered. In this condition, the biomass will grow too much and the F2M ratio will decrease, which means too much bacteria, not enough food. In this way, another biological process starts, which is the biomass decay. The bacteria starts to eat each other since the food is not enough for the cellular synthesis. The process is unstable and is up to us to take the corrective actions. If we start to waste the exceeded sludge, we are able to keep the system in stable conditions. Now let's make an example considering this process condition. So we have the inlet flow, 2,400 meter cube per day, inlet COD, 1,200 milligram per liter, BOD, 600 milligram per liter, then the oxidation tank volume is 5,000 meter cube, the F2M is 0.078 and the MLVSS 3,500 milligram per liter. Having this information, we can calculate the mass of MLVSS in the oxidation tank, decide the working SRT, the sludge rotation time of the system, and then calculate the sludge production in terms of MLSS. So with this formula, we can calculate the mass of MLVSS, just adding the concentration of the biomass and the volume of the oxidation tank. Considering the sludge rotation time of 30 days, this one is a decision of a process engineer, we can calculate, first of all, the mass in terms of MLSS. So starting from the first value, which is the mass of volatile solids, and considering the ratio MLVSS and MLSS by 0.7, we can calculate the kilogram of MLSS inside the oxidation tank. So with this information, at the end, we can calculate the production of sludge in terms of MLSS, considering 100% dry matter, which will help us to make the mass balance. So how to keep the working SRT? Please note that SRT is decided during the operation by the process engineer, and the SRT depends on the wasted sludge. Before to calculate the wasted activated sludge flow rate, we need to know the recycle ratio, the ml/VSS in the recycled sludge, we have to calculate also the recycle flow rate and the wasted sludge flow rate. So if we consider the RAS ratio 1.5, we can calculate using this formula. Of course, also you can carry out the laboratory test taking a sample. So we can calculate the ml/VSS in the recycled sludge. Just having the recycled sludge ratio, the concentration of ml/VSS in the oxidation tank. After that, we can calculate the recycled sludge flow. And at the end, using this formula, we can calculate the waste activated sludge flow because we know the SRT, we know the volume of the oxidation tank, we know the concentration of ml/VSS, and we know also the concentration of ml/VSS in the recycled sludge. So with these results, we are able to make the flow balance of this flow diagram. We have all the information because we know the inlet flow, we know the recycled sludge flow, so, and then we know also the waste activated sludge and the treated water that goes out from the system. So in this condition, we are able to keep the SRT of 30 days. So we have already seen the calculation for the sludge production and for the wasted activated sludge. But here, as you can see, we have some unknown parameters. The wasted sludge goes to the clarifier, from the clarifier to the thickener, and we need to know which is the flow and the sludge that from the thickener also goes to the dewatering unit. We need to know the final sludge produced, which has to be disposed, and the supernatant, which has to back to the equalization tank. So the sludge produced in the thickener is very easy to calculate since we already know this parameter. So the sludge produced in the biological oxidation tank, and 0.9 is the capacity of the thickener to catch the solids. So we can easily calculate, also consider 100% dry matter, the sludge produced in the thickener. As results, we have 750 kg per day. Starting from the sludge produced from the thickener, we can also calculate the final sludge produced after the watering, where in this case, 0.95 is the capacity of the watering unit to catch the solids. Also, the final results is considering 100% dry matter. In an easy way, we can calculate the sludge after the thickener considering the moisture, because as we know, after the thickener, the dry content is in a range of 2–3%. In this example, the sludge, the wet sludge, is 30,000 kg per day. To close the balance in the thickener, we can also calculate the supernatant, which goes back to the equalization tank using this formula, because we already know the volume in terms of meter cube per day of sludge that goes from the clarifier to the thickener. We know the wet sludge production in the thickener, so using this formula, we can calculate the supernatant, the thickener supernatant. So why we have considered at the beginning all the calculation using 100% dry matter? Because for the dewatering unit, the real dry matter depends on the type of system used. So considering the belt press, on average, the outlet dry content is around 16%. Using the decanter, the dry content is around 20%, and using the filter press is 25%. Having these parameters, we can calculate the wet sludge produced after each dewatering unit, and as you can see here, the filter press is the equipment that produces less sludge since the outlet dry quantity is higher. The difference in terms of outlet sludge between the belt press and the filter press is 36%, while between the decanter and the filter press is 20%. It's easy to understand how the installation of the filter press is more suitable since the outlet sludge to be disposed is less, and this one is reflected also on less money for sludge disposal. So, starting from the sludge flow that goes from the thickener to the filter press, which is this 30 meter cube per day, the supernatant using the belt press will be 25.5 meter cube per day. For the decanter, will be 26.4, while for the filter press, 27 meter cube per day. Now, going back to the flow diagram, we can make a flow and mass balance for the sludge treatment. For the thickener, we have 30 meter cube of sludge flow that from the bottom of the thickener goes to the dewatering, and we have 70 meter cube per day, which is the supernatant that from the surface of the thickener goes back to the equalization tank. Also, we know the sludge production, the wet sludge and the dry sludge considered 100%. As well as we have the same information for the dewatering unit, in this case considering the filter press. So we have 27 meter cube per day of supernatant, which come back to the equalization tank. And at the end, we have the final sludge production considering 25% of dry matter. And so you can use this procedure and calculation to check the sludge produced from your system. So thanks again for attending this webinar. So do not miss the last webinar, which will be extremely interesting regarding water and brine recovery. See you next week.
Thank you very much, Mirko. Thank you everyone for being here today, and see you next week. It will be our last webinar for this series. Please stay tuned, and any information will be available through our website, www.pantareiwater.com. There you will be able to watch this webinar and also all the past webinars. Please stay tuned. You will find all the information in our website and in the social media. Thank you very much.
Thanks again. Bye.